So let's look at doing arithmetic with Clojure. So let me go to my editor and I'll create a new file name arithmetic and name it clg.clg. Yeah, like if I forgot to tell, like all Clojure programs must have the extension .clg, right? So that's it. Or it's a convention. I'm not sure, but all the while I'm programming Clojure, like I have named a file, whatever file name it is, and .clg. And whenever you are naming a file like hello world or printing thing, don't put space, just put an underscore so that like that's how programming file gets named. And never ever use a hyphen in Clojure programs. Like that will cause problems in the future. So that's the thing. So let's go on and do some arithmetic. So I don't need this file list over here. So let me just close it. And let us just check the ripple over here, like the ripple is working. For that, we do a simple arithmetic. Test what is 1 plus 1, right? So yeah, it seems to work. And yeah, now let's go to our book. So we'll try this. What is 40 and 40 plus 2 is? So to do addition, you use a thing called plus function, right? So plus is actually, let's call whatever that comes after the braces as functions from now on, right? So to it, I pass two arguments, 40 and 2, and I just hit, you can hit, I think, Alt Enter or Option Return, depending on your OS, right? So it gives 42. 42 appears over here, and it also appears over here. So that's the thing. And let's try out our next thing, minus. Okay, so what is, okay, this is the minus function. What is 44? And we take away 2 from it, right? So let's try it out. This 2 is 42, right? So that's how it is. And for product, we don't use anything like X or something like that. That's how we use it in school. We just write the X for product and all those things. But in computer, X is also a letter, so we don't use it. So we use star over here, right? And so what is given over here? Like product of star 6 and 7, right? So we just put 6 and 7. Star is actually a function, 6 and 7 are arguments. Once again, it gives 42, right? Looks like 42 looks like a miracle number, right? So, and similarly, division, like you don't find a division symbol in your computer. So you can't do something like, okay, let me put this dot and let me just put a hyphen over here and dot over here or something like that. Okay, and maybe double. So like, yeah, this is how we write divisions, right? So hyphen hyphen and dot over here and dot over here. So that's not the way. You can't find division symbol in a computer keyboard, right? So maybe you can find it in calculator, but not in computer. Like calculators are very specialized machine. A computer is a very, very generalized machine. So let's find out what's 210 divided by 5. And it's still 42. So that's the thing. And it's not like you just need to pass only one argument to these mathematical functions. So let's find the sum of first 5 numbers. Okay, this says 10, but let me just limit to 5, right? So it says 15, right? And that seems very right. Okay, so that's the thing. And now let's do some complex operations. Okay, so let me just put this, and you tell me what the answer will be. Of course, you might have seen from my book, the answer is 3. So what happens over here is the innermost braces gets executed. So first this one gets executed. So this one is nothing but very same as this one. So this returned 15, as you can see over here. So now it becomes like as equivalent as, once this gets executed, it's 15. So we can rewrite it as like slash 15 and 5, right? And so when we execute it, we get it as 3. So that's how it is. So whatever is the most innermost braces gets executed. So to this plus function, we pass 1, 2, 3, 4, 5, and to this slash or division, we pass like the result of this and 5. So the result of this is 15, and 15 divided by 5 is 3. So that's what we get over here, right? So okay, yeah. So there are things that perfectly divide, like 10 and 5 and all those things, right? So that's the thing. But what if I put like 10 and 7? Okay, let me just compute it. It gives 10 by 7. This is nothing but this is a thing called ratio. Okay, so we can even do a type of it and find it out, right? So there is a thing called type. Maybe I'm just jumping ahead and all those things. Okay, it is a ratio, it's not a number, right? This is a very, very different type. Okay, so why I'm saying this is, okay, over here, like I'm just doing this one, right? So slash 1 and 2. So I'll get 1 by 2. And what this when divided by 3 is, like 1 by 2 divided, you just have something in half and you divide it by 3. Okay, so you get 1/6 of a portion, right? So maybe you can try it with a cake, right? So that's what we get over here. So this is actually a ratio. So wherever a perfect division is not possible, Clojure gives a thing called ratio, right? So that's the thing. How to avoid it? So maybe you can do something like this one. You have like 1 and 6, so that will surely give you a ratio. But then what you can just do is you can just make this thing as a floating point. Let me tell you what floating point is very soon, don't worry. Okay, so so numbers like, okay, like 1, 2, 3 are called integers. So like they don't have decimal point. But if you have something like, okay, like 4.0 or 2.0 or 2.7, these are called as floating point in computers. In short, whatever you have decimal is called as floating point in computers. And if you're just new to computers, don't go very deep into it because it might confuse you. If you just understand this, it's okay. And even if you don't fully understand it, okay, you might get it. So if you want a number rather than a ratio, it's better to give it as floating point. So that's how it is. So now let's try out like 1, 2.0, and 3. And 2.0 is a floating point. Let me just copy it and paste it. So even if you just have like one floating point, it's okay. Like it'll still give the output as a number rather than a ratio. So that's how it is. And this point zero can be put anywhere. So it can be put over here or it can be put over here. So whenever Clojure encounters integer and floating point in arithmetic, it it thinks, okay, like according to computers, floating points are more precise. So or something like that. And so it just does everything in floating point. That is, it does it with decimal. Okay, so and yeah, what are really floating points and what are really integers in computers, how they are represented is beyond the scope of this book. So I don't want to dwell into that. So that's the thing. That's the field of computer science and all those stuff, right? So uh, that's the thing, right? So yeah, you just put it anywhere and it still works, right? And okay, so you saw like okay, like uh, okay, so let me just take this, right? Okay, so you just put slash 14 and 5. They don't divide perfectly, so Clojure gives a ratio. But what if you just want to find the quotient of it, right? So quotient of 14 and 5, right? So oh, okay, sorry. There is a function called QUOT, QUOT, right? Okay, so and you just put it. Oops. And you just put it, you just get it, you just get 2. So 5 twos are 10, and you have removed 10 from 14, it'll be 4, so you can't remove another 5, right? So 2 is the quotient, and for reminder there is a function called rem, and put 14 and 5 and you will get like 4, right? So that's how it is. Okay, so yeah, this is quotient and reminder, right? So now let's calculate area of a circle whose radius is 7 units. Okay, so that's how it is. So we know, okay, like, okay, the area of a circle is pi r square. So the value of pi is 22 by 7. So I've just put slash 22 and that divided by 7. So that should give the uh, value of pi. And but yeah, it is a ratio, but just don't worry because we have a trick up our sleeve. Maybe yeah, you can just put even like 7.0, not a problem, right? But yeah, let us just have it like this for now. And now let me just, okay, and let's let the radius be 7. So this is pi. Okay, so pi, and that multiplied with radius, let's let the radius be 7. So it's pi r square. So r should be multiplied twice. So that's how it is. So this will give the area of circle whose radius is 7 units. 154 n. So what that n means, like, so okay, okay, I think, okay, yeah, this is what I suspect. N is for, stands for big ent or something like that. Maybe like, okay, right. I should have, I should do the type of it and see, and maybe that's how I just knew it then, right? So type of this one. So yeah, this is a big int. So some big numbers when represented as integers, they get prepended with n. So don't worry with this n, nothing will happen even if you just print it out. Okay, so if you print it out, it's going to be a normal number. So let me just pass this to a println, right? It's going to be a normal number. Oh, it still prints out 154n. Okay, that's not right, but okay. So like, okay, or if you just want to avoid it, let's do like this one. So let's put anything as floating point. Okay. So in the example, I would have put a floating point over here, right? But let's put it over here. This seems more neat, right? So that's how it is. And if I just press Alt Enter or Option Enter, this should get executed, right? So it's 154. Pretty neat, right? So that's how it is, right? So and you can call like what to say, mathematical things in Java. Like you have a math library in Java, right? And this math has a thing called pi in it, right? And you can call this in Clojure. So this is actually, you are just calling the constant pi in math module in Java, right? So now all we just need to do is use multiplication over here and multiply it with 7 and 7. So this is r square, right? So you just multiply and you should be roughly getting the surface area. You might ask, like, why we got 154? That's really right answer over here, and 153.9 and all those stuff. Look, there are some rounding errors and all those things, and I don't think even 22 by 7 is the accurate answer for the accurate representation of pi. Okay, so that's the thing. So there are some rounding errors and all those things. So if you dwell deep into computers and about the floating points and all those things, you will understand it, because in computers everything needs to be represented as ones and zeros. You can't do math like a human does. Okay, so that's the thing, right? Okay, so yeah, and over here, like, we are doing, okay, like, you just have this pi, so for that we just put mat pi. Okay, and there is also a thing called mat pow in Java, like, to find the power. Okay, so uh okay, power, and then 7 raised to the power of 2. This is 7 square actually, right? So now let me execute it, and almost very, very same. In fact, the same answer, right? So that's how it goes, right? So that's it for arithmetic now. Uh, we will look at types of numbers in the next video.